This is problem number 10 from section 4.4. It says a bird population can be modeled by f of x equals this polynomial, where x equals 1 corresponds to June 1, x equal 2, June 2, and so on. Find the days when f estimates that there were 3,000 birds. Now f of x is the population, x is the date. So when they say 3,000 birds, they're saying f of x is 3,000. So let's start there by saying 3,000 equals x cubed minus 66x squared plus 1,052x plus 1,152. Now I need to get this equal to 0 in order to solve the polynomial. So I'm going to subtract 3,000 from each side. So I end up with 0 equals x cubed minus 66x squared plus 1,052x, and 1,152 minus 3,000 is negative 1,848. Now at this point, I've got 4 terms. I said earlier in one of my videos, if you get 4 terms, you should probably try to factor by grouping. But because these coefficients are so large, I don't think factor by grouping is the way to go. I think that's going to take a long time. You could use the rational zeros test, but 1848 has a ton of factors. So because it's got so many factors for the rational zero test, I think that we're probably going to ignore that as well. I think we can just graph it and look at the graph. You know, we can estimate. It says estimates, so it doesn't say exact, so we might as well just use a graph to do this. So let's plug in y equals, and we'll put in x cubed minus 66x squared plus 1,052x minus 1848. Enter. Now let's go to the window. Now it says we want to know when we got 3,000 birds. So I'm thinking we probably want to go up by, I don't know. Well, the x values maybe go from 0 to 100. So let's go 0 to 100 days out. And we'll go up by ones. The y values then, let's go from 0 to 5,000. And maybe the y values we want to go below just so we can see, because we're looking where it crosses the x-axis. So for the y values, let's go ahead and put negative 5,000 to 5,000. And we'll put it as, I don't know, going up by hundreds. Let's see how that works. Let's go up by 500. It's a little better. So I'm just guessing here, and if it doesn't work out where we can't see the graph well, I'll fix it. It looks like we can see the graph, right? We know that it's a cube function, so we've got 3 zeros here. We can see it pretty good. So we're going to go, and we don't have to look at anything. We're going to use this calc button, which is the 0 button. We're going to find the zeros, and all we've got to do is put in our left bounds and our right bounds. So our left bound where's our x value at? Oh, it says our x is way out there. And we're bringing it back. Okay, there we go. Left bound, right bound, guess it. It says one of our zeros is x equal 2. If you see that right there, x equal 2. We know the y is 0 because it's 0. So x equal 2 is 1. Or, let's go to the other 0. So we're going to do second calc, 0. And we're going to go left bound, right bound, guess it, 0 is 22. So x equal 22. And then we're going to do it again for the third 0. Left bound, right bound, guess that. That's 42. So, or x equal 42. So x equal 2. We gotta once we find our zeros, we gotta like interpret this. So this is when they found 3,000 birds. So these are the 3 different spots. Well, it says x equal 2 is June 2nd. So June 2nd, and they didn't find 3,000. There were 3,000. Sorry, there were 3,000. They didn't find 3,000. So June 2nd and June 22nd. And now this is past June. Remember, June has 30 days. So we're going to subtract 30 from this to find out what day in July. Well, 42 minus 30 is 12. So that's July 12. So June 2nd, June 22, and July 12, there were 3,000 birds for the bird population. So I hope that makes sense how we use the graph to solve this. All we did was set the original polynomial equal to 3,000, subtract it over so that the polynomial equals 0 so we can solve it, and then we just found the zeros and interpreted them.